Okay, now we've talked about how ionic and covalent compounds form and why they form. Let's have a look at some of the differences between them. Ionic compounds, remember, are formed between metals and nonmetals. And typically, covalent compounds are formed between nonmetals and nonmetals. Covalent compounds are sometimes called molecular substances. So, let's have a look at some of the properties. Solubility. Ionic compounds, because they've got ions, which are charged particles, they like polar solvents, like water. And we're not going to talk about this too much now, but essentially water molecules have got little charges on them. So ionic compounds that have charges, they like the charges on the water molecules. Covalent compounds don't have little charges on them, so covalent compounds are not compatible with polar solvents. Don't worry too much about that, but remember the fact ionic compounds are soluble in polar solvents. Covalent compounds are not very soluble in polar solvents. The solubility in non-polar solvents, for example cyclohexane, ionic compounds don't like non-polar solvents. Covalent compounds do like non-polar solvents, so they have high solubility in non-polar solvents. How volatile are they? How easily do they evaporate? Well, ionic compounds, because they have these strong forces of attraction between the oppositely charged ions, they have very low volatility. They don't evaporate. But covalent compounds, they have high volatility. You think of alcohol like ethanol or water. A puddle of water will evaporate on a warm day quite quickly. Hydrogen gas, it's a gas at room temperature. Bromine liquid is very volatile. It forms bromine gas very quickly. How well do they conduct electricity? Well, as solids, neither of them conduct electricity. So when they're solid, the charge cannot flow through them. They won't conduct electricity. When they're liquid or in solution, ionic compounds will conduct electricity, but covalent compounds still won't. We'll talk about that more in the next section. Melting points and boiling points, they're high for ionic compounds. Sodium chloride, for example, common salt in your kitchen, has got a melting point of 800 degrees. Covalent compounds, they've got low melting points and boiling points, which is why many of them are gases, like ammonia or methane. They're gases at room temperature because they've got low melting points and boiling points. Okay, lots of things to remember there. We want to just take a moment to try and explain the differences in the melting points and the boiling points of these compounds. So ionic compounds, they're made up of positively and negatively charged ions, and they form these crystal lattices with strong ionic forces between the oppositely charged ions. That means that lots of energy is required to break down this structure. To break one of these bonds will be quite easy, but to break down all of them in a three-dimensional structure takes a lot of energy, which is why they tend to have a high melting point. Like I said, sodium chloride melts at 800 degrees C. Something like hydrogen chloride, which has a covalent bond in the molecule, well, these are molecules, and between the molecules, it's called the intermolecular force, there are very, very weak forces. Within the molecule, that bond there, the covalent bond, is quite strong. But between the molecules, there are weak forces. So that means very little energy is required to overcome this force. So hydrogen chloride has got a very low melting point and boiling point. It's actually a gas at room temperature. Okay, get your head around that. These are just some examples of molecules just taken from the internet, just to show you that you now know what these little symbols mean. For example, that symbol there means a double bond. That means a single bond. There's a single bond. There's a carbon-carbon double bond. These are all covalent bonds. Okay, there's something complicated going on here. Don't worry about that. But you can see that these sticks, whenever there's two lines, it's a double covalent bond. When there's one line, it's a single. Okay, have a go at the questions on these pages. Read through the text to get some extra info and make sure you understand the basics.